All right, so here we go with the notes for 8.2. These are fairly short, but we're just going to review function notation and some of its uses. So a little reminder here. Let me just move my phone back. If you're talking about function notation, if you have something like f of 2, actually if you have something like f of 2 equals 1, the 2 is the x and the negative 1 is the y. So it means that x equals negative 2 and f of x, or y, is equal to negative 1, which means that the graph passes through that point to negative 1. So you'll remember if you were given function notation, and for example, if you were going to graph that, and we talked about this in the previous section, you know that the f of x means exactly the same thing as the y. So one way to use this is if I have a picture of a graph, and if I want to find f of 1, basically that means when x is 1, what is the y? So if I look at my graph, when x is 1, what is the y that goes with it? Well, you can see the y is right here. It means that the y is 2. So the point 1, 2 lies on the graph. If I want f of negative 2, that just really means, okay, when x is negative 2, so there's x being negative 2, what is the y that goes with that? Well, the y is down here, and it looks like the y is negative 3. If I want f of 5, well, that means x is 5. 1, 2, 3, 4, 5. What is the y that goes with that? Well, it looks like it's about right here. We're just going to estimate. It looks like it's about 2 1/3. We're not going to go crazy. So that's what that function notation means. So now we're going to go over some fairly basic, I like to call these parent graphs. Nonlinear functions means that these are not going to be lines. We just reviewed lines. So these are 3 different functions, very famous functions that we are going to graph a lot of, and you should know how to graph them fairly quickly. So the first one is f of x equals x squared. This is called a quadratic function, and we're going to do a lot more with quadratics later. And hopefully you remember that when you have a quadratic function, or a function that has a degree of 2, it means you get a parabola. So if we wanted to look at this very basic function by plotting some values, well, if I plug 0 in for x, 0 squared is 0. If I plug 1, oops, let's try that again, that's 0. If I plug 1 in for x, 1 squared is 1. Plugging in 2 for x, 2 squared is 4. If I go negative, if I plug in a negative 1 for x, negative 1 squared is positive 1. So right there you can see it's not linear. And plugging in a negative 2, I'm also going to get a positive 4. So you can see that this is a very basic, what we call a parabola. And again, we're going to do a lot more with parabolas a little bit later on. The next one is an absolute value function. That's what these symbols mean. And if we do the same type of thing, we'll make an f of x chart. Let's plug in 0 for x. Well, what's the absolute value of 0? It is 0. Remember, absolute value is always positive. It's a distance. If I plug in 1, the absolute value of 1 is 1, so 1, 1. And you can see that 2, 2 will be a point on the graph, 3, 3, and so on. But if I go negative, if I plug in a negative 1, what's the absolute value of negative 1? It's positive 1. The absolute value of negative 2 is positive 2, and it's going to keep going that way. Now, this is not a parabola. This turns out to be what looks like a V. Whenever you have an absolute value function, it's going to turn out to look like a V. It's literally going to have a pointy bottom or a pointy top if it's turning down. And finally, our last function we're going to quickly look at is the square root function. So if we do the same type of thing, let's plug in some values. Let's start with 0. The square root of 0 is 0, so that means that the origin lies on this graph. Let's plug in 1. What's the square root of 1? Well, it's 1. Can I plug in a negative number? No, because those numbers are complex or imaginary, so we're not going to go there. I can plug in maybe 4, though. If I plug in 4, the square root of 4 is 2. Notice how I'm kind of picking 1, 2, 3, 4 convenient numbers. How about if I plug in 9? What's the square root of 9? It's 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. So there's a curve to that function. It looks kind of like that. And that's the end of 8-2.